Dear students, today we are going to learn programming language, the basic concept and workflows. Can you answer me a question that why computer is omnipresent in the society? You go to your university, you go to a library, you go to a medical health checkup facility, you go to anywhere, a railway reservation counter, a railway ticket counter, everywhere you find a computer. So can you name any other device in the society that is applicable to entire, walks of life? You won't tell a, you can't tell a particular device. But computer is the only device which is omnipresent in the society, and from alchemy to zoology, A to Z, every walks of life is basically dominated by this machine. Why? The reason is that computer is a programmable device. You are a librarian, you can program it for to suit the library operation. You are a railway system developer, you can do that for railway for the railway system. You are working in an organization, you can do it for the management of that organization. So everywhere, similarly with the health facilities also, so everywhere you can program this particular device. That's why it is omnipresent. It's a programmable device. Now, when you are saying that computer is a programmable device, very basic question comes that what is a program then? And how it is related to a software? Because the moment you are saying computer, you are basically saying about computer software. Everywhere the roles are managed by the software. Computer is a tool, a device on the top of which you program it. Programs are represented in a group of program represented in the form of a software. That software actually manages the soul. That's why computer is omnipresent in the society. So we need to understand here what is a program, why a program is the unit, fundamental unit of a software, how to develop a program, what do we mean by programming languages, how they can be categorized, what are the examples of different categories of high level programming language, what's the role of translator play in converting a human readable computer program or script into a machine readable entity. So that we are all are going to learn definitely a panoramic view of the programming languages, the basic concepts and workflow. So let us start. As we said that you go in any walk of life like education, manufacturing, business, communication, industry, like different kind of industry, automobile industry or else legal firms, government institution, universities, library, you are finding a computer. Computer is a tool or device. That device is programmed to perform a certain kind of job suitable to that particular organization. And that's why it is called a programmable device. So a program, you can see that basically a program is performed or a program is designed to solve a particular task, a particular problem. This is basically problem solving tools. The programmer first writes, takes the problem and first writes a set of steps how to solve that particular problem, and that we call algorithm. That algorithm they are converting into a flowchart, that is the visual representation of the solution. Then they select a high level programming language of their own choice, and then they transfer that algorithm or flowchart based problem solving sequences inside that high level programming language by following the rules, syntax, semantics of that particular language. We are getting a program. So a program can be defined as a set of logically related instructions. And what is an instruction? An instruction is a command given to computer to perform a certain kind of job. And what is a software? A software is then a group of related programs. And what is a software suite? Like, you say office automation suite, like MS Office suite. So these are basically a group of related software. So this is basically the hierarchy: instruction to program, program to software, software to software suite. And this is the in the screen you can see that how this entire process is happening inside inside the workflow, from solving that particular problem to converting that solution into a program, and then how to execute that particular program. So here you see uh, the most important part is that uh, the programming language. By using the sequences and syntaxes of a given programming language, you are writing that one, then you are transforming that particular program into an executable file or binary file, so that your computer can understand that. By reading that binary file, computer is actually designing different kind of or performing different kind of problem solving process. Okay. So if we now go to this particular programming language, domain. So a programming language, why it is called a language? Because it has got a formal system of instruction, a particular set of syntax and semantics, and programming languages can be categorized into three main groups, or rather two broad groups, and altogether there are three groups. So programming language can be categorized into low level programming language and high level programming language. Low level programming language can again be of two types: machine language and assembly language. So we human beings prefer to write a particular program which looks like a natural language or an English like language, kind of thing. So when you are saying int a, that means you are readily understanding, you are declaring a variable a which is integer in nature. So that kind of human like expression of different kind of instruction is basically the feature of high level programming language. But some programs you have to write in machine language or assembly level language, like device driver, very low level of jobs, like operating system to a particular device. You are having an interface called device driver. So device drivers like printer driver, network driver, storage driver, these are basically written in assembly level language. And a machine do not understand high level language or assembly level language. It understand only machine language, which is written in the form of 1 and 0. And there lies the role of a translator, which takes a high level language or an assembly level language to convert into machine language in the form of 1 and 0, which is readily understandable by the hardware of that system. So by understanding that machine language based system, a computer executes the job. So altogether, it's a hierarchy: high level or assembly to machine language. Now, how this four, no, three component or three different types of programming language differ from each other. A machine language we generally write in the form of 1 and 0. And as it is written in the form of 1 and 0, it is very, very difficult to read, write, and debug a programming language which you are directly developing by using 1 and 0. For example, in the screen, you can see that an instruction I have written here: 1011, then four zeros, then 011, four zeros, 1. So this is a binary instruction to move data into a register. So if I misplaced 10 with another 1, then it's very difficult for me to debug it. That means to correct it, to check the error, to detect the error. Very difficult. But the advantage is that it is readily understandable by machine. So it is very machine friendly, a machine language, but not human friendly. Then comes the assembly level language, where we use a few codes, alphabets, like MUL for multiplication, ADD for addition, SUB for subtraction. And here again you see I have written a code here. MOV stands for move, AL 61H. That means it will take the 61 hexadecimal value of 61 and move that value to the register named AL. So this kind of program we call assembly level language. As I already told you, mostly device driver are written in assembly level language. And then comes the high level programming language, what we are going to discuss in more detail. So here I can write print hello world. So it's a natural language kind of thing, English language kind of thing, what I understand very easily. But at the same time, it's very difficult to understand by a machine until and unless you translate it in the form of one and zero, which is the component of machine language. So that's why in the bottom part of the slide, I have shown you that how from machine to high level language, it is becoming human friendly, and how from high level to machine language, it is becoming machine friendly. And there we need a tool, a third party tool, which will translate my high level language or assembly level language into the corresponding machine language entity. And that we can execute in a computer system. So there comes the role of the translator. Translator, you see, there are three kinds of translator. So one is assembler, which is basically utilized to translate an assembly language into a corresponding machine language. These are very fast because most of the things are written in the form of one and zero, only a few codes. So that codes requires interpretation. And one thing you need to remember that assembly level language and machine language are generally machine dependent, platform dependent. That means you have to decide for which hardware architecture, which particular operating system I am writing it. Whereas high level programming language are machine independent. Once you write, it can run in any machine, and it's platform independent. Most of the cases, the scripting language, say one particular program in PHP or Python can run equally well in Windows or a Linux operating system. So that is one of the major difference between high level and low level programming language. But again, coming back to this particular point, what an assembler is doing, it takes an assembly language program and converts into the corresponding machine language process. And there are different examples, as I already told you, different device driver. But as I said, that our main target is high-level programming language. There are two kinds of translators are working. One is interpreter. It takes one line at a time, then translate it, and then goes for the next line until and unless their error is detected. The moment it will find an error in the program, it will stop there. So line by line execution is done by interpreter, like your web browser. The moment you are opening an HTML page, it reads each line. Suppose up to one particular block that program is right, it can display up to that particular block. The moment your program goes south, goes wrong, then it will stop there displaying the page. So your browser is the classic example of interpreter. It takes one line at a time and then translate into corresponding what you see, what you get more. Another particular translator that we generally use in a computer system is called compiler. It never goes one line by line. It runs, checks the program once or twice, converts the entire program into the corresponding machine language program through translation at once. If there is no error detected, if error detected, it will not compile. It will report you the syntactical error. It cannot report you semantic error or logical error, but syntactical error it can report you. And again, you follow that report. For error report, you rectify, recompile, and rerun. So it takes the entire program once and translate it. That's why it is called compiler. It compiles the program, and that compiled code can be saved for future use. Every time you don't have to compile it if it is successful. So that is the difference between the assembler, interpreter, and compiler. Then, as I said, that we need to know that how a particular this programming process we generally execute right from the developing stage to running that particular computer program in an operating system or in a hardware architecture. So here you can see that how it works. First, we write a high-level programming language, which alternatively we call source code. Say, for example, by using C programming language, I am writing a program which takes input of three integers and determines which of these three is basically the highest one. So I need to write that algorithm, that flowchart, that algorithm and flowchart I will write by following C programming language syntax and semantics, and I will develop the source code. For example, a.c. Then the moment my a.c or source code is ready, I am ready to compile it. So I will throw it to a compiler. Like in case of Windows, we can use Turbo C compiler. In case of Linux, we can use GCC compiler, GNU C compiler. Then that compiler will produce an object code. Object code will be merged with the routine libraries through a system called linker. Linker is the part of the compiler family. So linker will link the object code with the routine library. And finally, after integration, your object code with the routine library will be having an executable program or binary code. This is the process. Source code to compiler to routine library, then your binary code or executable code. Then that binary code I can distribute, anyone can download, anyone can run for any purpose for any number of time. But here lies one particular question. The question is that the entire process is irreversible. Say, for example, I can move from source to object to binary code or executable code. But if I give you that executable code, you can spend your lifetime. Then also you cannot go back to my source code. You do anything. There is no translator, no software available which can reverse engineer your binary code into a source code. And there lies the business of software industry. What they generally do, they compile their source code, they keep it with them only. They distribute you the binary code. The moment you need some changes, you need to go to them, you need to pay them, and you get the next version. So every time they release the next version, version 2, version 3, version 4 of a software, they do the same thing. They never distribute, the commercial entities never give you the source code. You are only having binary code that you can run for any number of time. But remember, the process is irreversible. You cannot go back from binary code to source code. Now, this is basically the main or key point for software industry. They never give you the source code so that you are always depending on them. Now, let me show you a particular example here. So here you can see I am using an Windows operating system and developed a very simple C program that it will print welcome to XYZ. Something is written there for 10 times. So here loop I am running, you can see from 0 to 9. So this is the source code for C1.c. Then you can see this particular source code, the moment I have completed this one and I have given the dir command, you just note the size of this source code, only 117 bytes and name is c1.c. So now you see the moment I give here dir command, it will list that in this particular directory only source code is available c1.c, and please take a note of the size of this file, only 117 bytes. Now in the next step, what I will do, I will throw this particular source code into a compiler. As I said, this is a C program. So I have utilized here TCC, Turbo C compiler. And as my program has got no error, it will be cleared by the compiler. It will convert this source code into object code, and object code will be converted into binary code by matching it with different kind of routine library. For example, what do we mean by routine library? So there are many functions like printf, scanf, enter. So these are the functions we basically rewritten inside the library of the compiler, and there the moment you are calling that function, the exact program from the routine library will be attached with this particular program. Now, with the result of this, you see the moment my software program compilation is done, if I again use this dir command, this time you see my folder C part includes three files. C1.c, the source code, same 117 bytes. Then it prepares C1.obj, that is object code, which is almost double of the original source code. Then it is linked with different kind of routine library like printf, scanf, and you see the magnitude of this binary code or c1.exe. It is almost 600 times more than the original source code. The entire thing goes into 6578 byte. Why it is happening? Because lot of functions you have called in my program. I have utilized scanf, printf. So these two programs are coming from routine library merged with my source code, and my binary code size is huge. Then I will, suppose I am a software vendor, I will distribute you this c1.exe, not c1.c, not c1.obj. And that c1.exe you can run by either calling c1 or c1.exe, and it will perform the job. But suppose here it is, printing this line 10 times. Now, suppose you need it 200 times. You need to come back to me. I will just change my, program from the loop from 0 to 9 previously. Now I will run 0 to 199, recompile, rename it as a version 2, and will sell you for another lakhs of rupees. So this is basically the software industry is doing, and the process is, because the process is irreversible, and they give you only access to the binary code, not the source code. So this is the process happening when you are developing a particular program. So if we now want to summarize this process, so what is the programming steps in programming? First, you define the problem. So it analyzing the core and peripheral problems that to be solved. Then you plan the solution, how to solve that particular problem by designing a step solution, and that solution often you encode as a pseudocode, and pseudocode is converted into flowchart. Then on the top of that flowchart, you write your codes in by following any programming language like I did in C. Then you translate it or compile it. Finally, if there is an error, you debug it. Debug means error detection in a program. And finally, you prepare a small documentation so that others who are utilizing that particular program can readily know what's the logic, or why this particular step, and so on. So these are the six stages, basic stages of any program kind of job. And this particular solution planning can be supported by pseudocode and flowchart. Let us go for an example. Let us say the problem at hand is that we need to take input of three integers. Then my program will read all of these integer, will determine which one is the highest amongst these three. So this is the pseudocode or algorithm. So I start beginning, take the input of ABC. If A greater than B, then check also if A greater than C, then A is the highest. If A greater than C is not true, then print the highest integer is C, because A is already greater than B. So that's why we can deduce this fact. And this if has an else, where if B greater than C, then print B, if no, print C. So this is the pseudocode or algorithm I have written, not following any programming language, but just on the basis of the concept that you will compare these three and then determine which one is the highest. Then this particular algorithm will be quite clear if I design a flowchart like this. So I'll start by taking input of three integer. Then first I will ask a question, is A greater than B? There are two possibilities, yes or no. If yes, then asking if A greater than C. There is again two possibilities, yes or no. If yes, print A is the highest. If no, C is the highest. And here if we follow this route that A is not greater than B, then compare B with C, then B is greater than C. There can be two sets of answer, yes or no. If yes, print B is the highest, else print C is the highest. So if I actually prepare this kind of visualization through flowcharting, then it will be very helpful for me to code the program by following any programming language. And you already know that how to code a program in C and so on. So there are different kind of programming language, and for different domains. For example, there is ALGOL for mathematical problem, BASIC for multipurpose, COBOL for business, Fortran for math and engineers, Pascal, again a multipurpose programming language, then Lisp for AI and expert system. Lisp is actually developed by John McCarthy way back in 1958. Then Prolog, another programming language for AI ML based system. C and C++, very popular. These are algorithmic, high level programming language. For application program, we use Java, GUI based web application, VRML for virtual reality, and so on. Then the latest, family members of the family of programming language like Perl, practical extraction report language, PHP, then Python, ASP, active server pages, JSP, Java server pages, and so on. And PHP stands for hypertext preprocessor. So these are all domains, programming language, and their domains or target domains or specific domains. But if we want to categorize this high level programming language, how to do that? So here you can see this particular scheme we can follow, that classification of programming language. Programming language can be divided into three fundamental groups: procedural high level programming language, non-procedural high level programming language, and another one is problem oriented to solve a particular given domain problem. So procedural can again be divided into three groups: algorithmic, object oriented, and scripting. Non-procedural, which normally we use for different kind of AI ML based programming, logical programming, can be functional like LISP, list processor, or it can be logic based like Prolog, programming in logic. In the problem oriented domain, we have symbolic, different domains are there. For example, mathematics, chemistry, they have, peculiar kind of formulas, symbols, etc. To handle that particular domain, we need some specialized, programming language like KML, chemistry markup language, or Mathematica. So similarly, different kind of symbols, numerals, and publishing industry like LaTeX and so on, we need it. So these are called problem oriented. Now, if we go for a overview of this one, procedural programming language generally follows or solve a particular problem through a sequence of operations, sequence of steps. That's why these are called procedural, follows a particular procedure. Then non-procedural follows different kind of, logical approach to solve a particular or to derive things on the basis of the available facts, which are very important for AI/ML programming. Then, as I said, problem oriented deals with different kind of domain problem solving like chemistry, math, publishing industry, and so on. So within procedural, we have algorithm. The best example is C. It involves step-by-step problem solving procedure. Then we have object oriented, which uses object to represent data and methods. We have scripting. Most of the scripting programming language we use for web interface like Python, PHP, Perl, etc., JSP. Then functional and logical, this basically, as I said, the LISP or Prolog are basically used for generating different kind of AI/ML based system. So if we go by the example that let us give one example from each group. So in case of procedural algorithmic, the best example is, Fortran, COBOL, C. In procedural object-oriented, the best example is Java or C++. For procedural scripting, we have Perl, Python, PHP, JSP, and many more. If you come to non-procedural, the functional, the best example is LISP, and logical, the best example is Prolog. If you come to problem-oriented, from symbolic, MATLAB, from numerals, Mathematica, or for publishing industry, LaTeX. So in this way, we are basically categorizing and classifying. One of the beauty of this categorization or classification is that the moment a new programming language will come, you can easily place into this grouping, because this grouping is very fundamental in nature. And now we know a bit about program and software. We already know a program is a set of logically related instruction and a software is a set of logically related programs. But again, I am asking, what is a software? Can we view a software from a different point of view? Yes, of course. Because you see, a software is also a digital version of human knowledge. Let me explain. For example, you know little bit of programming language like Java or PHP or Python, and you want to write an accountancy management software. Can you do that only with your knowledge of programming language? No, a big no. You need the domain knowledge, how people manage accounts, what are the double entry system, how to keep accounting records, how to store it. All you need to know, the workflow you need to know. Suppose again you want to develop a software for library automation. You again know, little bit of Perl, PHP, etc. And you are a very good programmer. Let's for the example, for the sake of example, still can you do that without knowing that how library works, what's the workflow, what do we call housekeeping operation, how books move from one section to another section? Not possible. So for each and every software, you need domain knowledge first. And 80 to 90% is coming from the domain knowledge. And that domain knowledge you are converting into the digital version by using a programming language. So if that is true, most of the domain knowledge we are having in the society coming from the public domain. Lot of textbooks available, lot of research papers available, from where we actually get the knowledge, and that knowledge is public domain knowledge. Now, if I am using a public domain knowledge and with the virtue of my knowledge of programming language, I developed a software, am I ethically in a position to sell that software? That question asked by a very great computer scientist, Dr. Richard Stallman, way back in 1984. That are we going in the right direction? Are we ethically in a position to sell the software? Because every software is basically representing of human knowledge and human knowledge available in the public domain. So how a public domain entity or goods you can sell again? Is it ethical? So he raised that question, left IBM, and started developing a foundation called FSM, Free Software Foundation, which later originated as Open Source Software Community. And Open Source Software Community actually developed 10 commandments, like 10 commandments of Bible. They developed 10 commandments. Free distribution. Every computer software must be available to everybody free of cost who are interested. Otherwise, if software is paid, entity, then only a very huge resourceful people will utilize the software, and there will be again a divide in the society called digital divide. So let's democratize the software. Let's everybody invite everybody to use it. So free distribution of the software is the first commandment, followed by the source code. Commercial entities do not provide you the source code. Open source said that you make the source code available to the user so that they can customize, they can change, they can read, they can write. Then all the software based on that particular software, what you have changed, that is also should be open source. So suppose you have taken Koha, changed something, that means you cannot sell that. That derived work from Koha should also be available as an open source software. So in this way, there are 10 commandments, but these 10 commandments are going to support four fundamental freedoms. That is freedom to read, freedom to write, freedom to distribute or share, and freedom to redistribute of the derived work. So these are the 10 commandments and the foundation of open source. And open source, you see, the foundation is open source programming. And again, if we divide the software into two groups, so we already know by their domain of activities, they can be divided into system software and application software. But as per the distribution policy, they can be divided into closed source software, where source code is not available, and open source software, where source code is available. Closed source can again be of two types, either commercially available like Windows, MS Office, or closed source but available freely. So lots of software stuff you are downloading from internet to use in your computer, the demo version, etc. These are freeware, but not source code is not available. So open source is basically dominating the library world. You name it, we have it. Library automation, Koha. digital library, disk space, eprint, greenstone, open source operating system, any Linux based operating system, open source programming environment, Python, PHP, Perl, we all having it. Oh, office automation, we have open office, LibreOffice. So open source is coming as a viable alternative to their commercial counterpart. And mostly library people are using open source software. So if you compare this commercial freeware and open source, you can see the basic difference is that in case of open source, both source code and binary codes are available at no cost, where in case of commercial it is available against fees, whereas in freeware available the only but the only binary code. As source code is available, this open source software can be customized extensively, but commercial software or freeware cannot be customized. In case of commercial software or freeware, license is basically restrictive in nature. It always says that what you cannot do. If you ever read the EULA, End User License Agreement during installation of Windows operating system, you will hesitate to install that system in your machine because it says the moment this installation is completed, you have to destroy the CD or DVD. The moment it passes 5 years, you have to delete this operating system. So this kind of restrictive clauses are there in case of end user license agreement. But whereas open source is also licensed, but this license is giving you freedom, freedom to change, freedom to share, freedom to distribute, freedom to redistribute, freedom to develop, derive to work out of it, and make it again available as open source product. So these are the freedoms available like GPL, GNU public license or FreeBSD, MIT license. These are all associated with open source software. And as I said, that in case of libraries, the most important architecture we call LAMP architecture, where every component is open source. Linux as an operating system is Linux kernel-based operating system. Apache as web server, again open source. MySQL or MariaDB or PostgreSQL as backend RDBMS, open source. Perl, PHP, JSP, all are open source. So entire library software, as I said, ePrint, DSpace, Koha, Greenstone, and you name it, all are mostly open source. And that's why we have to give extra, emphasis on learning this open source architecture. And there are a lot of domain specific tools also for other than the code part of libraries like discussion forum, bulletin board, blog development, your website development mostly happening through WordPress, Drupal, Joomla, all are open source. Library automation, Koha, Emilda, PHP My Library, digital library, Greenstone, ePrint, DSpace, Fedora, e-learning, Moodle, eTutor. As I said, you name it, we have it. So these we normally use in libraries for providing different kind of library services, including office automation, graphics, web authoring tools, and whatnot. So at the end, I will tell you a few suggestions, reading suggestions. Like mostly these are available from the web in open textbook. Like let us see from Kanikar or programming language for non-programmers. You please read these books and lot of video tutorial you will be having from NPTEL also or EPG Patsala also.